welcome to the another session on computer network, which is data link layer, which is data link protocol. So what is meant by data link protocol, and what is the advantage and what is disadvantage on data link protocol, and how to usage of this data link protocol. So all these things today we are going to discussing about in this session. So when discussing about this data link layer, so as we know about this data link layer is a error-free transmission layer. So here we are able to correct the error mechanism as well as delete the mechanism, which means we are able to control the errors. We are able to control the error values. At the same time, we have to follow a flow control mechanism. So to usage of all these things, we are going to implementing some kind of protocols which we calling as a data link protocol. So data link protocol is apparently we calling as which we are used in the data link layer protocol. So which is helpful to develop the error-free transmission for signal transmission from source to destination. So in this data link protocol can be categorized into two different categories. It is classified as two different categories. One is noiseless channel and the one is noisy channel. So as we know, when the signal is transmission from source to destination, so most of the scenarios we are going to using in the wireless communication methodology. So in the wireless communication, we are facing the issues with noisy values only as well as noiseless channel values only. So if we are using noiseless channel, which means a noise-free signal values, noise-free signal transmission from source to destination, we are going to using the two protocols, which is simplex protocol as well as stop and wait protocol. And the same way in the noisy channel also, we are going to using three different protocols, which we calling as a stop and wait ARQ, go back and ARQ, and select to repeat ARQ. ARQ in the sense a automatic repeat request. So if any signal is transmitting from source to destination, if any frames are damaged, for example, if I'm transmitting n number of frames, I'm transmitting from source to destination. So if frame 1 is successfully transmitted, but the frame is unsuccessfully transmitted, so we are getting this negative acknowledgement. So without able to reinitiate the retransmission process, the automatically a repeat request is initiated. So the frame 2 is again retransmitted from source to destination. So that we calling as a ARQ mechanism, which we calling as a automatic repeat request mechanism. So in the noisy channel, we are facing major issues of signal damage, signal losses. So we are going to using three protocols, which we calling as a stop and wait ARQ, go back and ARQ, and select to repeat ARQ mechanism. So we are going discussing about one by one in this session. So what is simplex protocol in the noiseless channel? So as we know, noiseless channel, which means so we are not getting any kind of noise in this channel. So 100% efficiency is there, and we talking about the redundancy mechanism as well as the accuracy mechanism is very high in this noiseless channel mechanism. So in the noiseless channel mechanism, the first one is a simplex protocol, which means the simplex in the sense when the signal is transmission from only one direction mechanism values only. For example, we taken about this FM communication, the signal is transmitted towards only in one way direction. It won't taken about any kind of information from another direction. The signal is only in one way direction, which we calling as a simplex transmission process only. We calling as a simplex data transmission. So in this one, data is transmitted from between the source and destination. So here we are able to establishing some kind of hub points or some kind of host point we are initiated between the source and destination. So based upon a nodal point or based upon a host station, the information is transmitted between the source and this receiver. So here already the connection is established perfectly. So there is no chance of signal losses and there is no chance of channel losses values only. So the signal transmit towards only one direction, which we calling as a simplex direction. And while we discussing about this processing time and the buffer phase, so when taken about this processing time, how much amount of information is transmitted and how much amount of time it taken. So when discussing about this propagation delay of signal transmission from source to destination, it purely depending upon the data rate perspective. How much amount of data rate is there between the information is transmitted from source destination, that we calling as a processing time. So it will be very less depending upon the data rate values only. When data rate is very high, the signal transmission also very high, the processing time is very less. And while discussing about this buffer space, if the n number of frames are transmitted from one to another frame, so we discussing about buffer frame because we are need to get the acknowledgement of services. So we discussing about the buffer frame as well. And another important topic is, in this one, in the simplest protocol, never damage or never loses the frame values only, because the one-way communication establishing, once channel communication is establishing, until the channel is breaks, until the communication is breaks, the signal is continuously transmitted. So which means never damage my signal values. So when you see this one, so here we'll see the simplex wait protocol, so which we calling as a stop and wait protocol. What is in the stop and wait protocol? So here previously in the session, that is one-way transmission values. If n number of frames are transmitted, these frames are continuously transmitted. They won't get the any kind of information from the receiver side, whether go for this a positive acknowledgement or negative acknowledgement. But in this one, the stop and wait protocol, when the information is transmitted from source destination, if frame 1 is successfully transmitted, so it has to wait for the acknowledgement from the receiver section. That we calling as a stop and wait protocol. So once after frame transmission, frame 1 is successfully transmitted from source destination, it has to be wait for some random amount of time to get the acknowledgement. Once we get the acknowledgement, it has to initiate the second frame. If we get the positive acknowledgement, it has to transfer the frame 2. If we get the negative acknowledgement, it go for this retransmission of my frame 1. That we calling as a stop and wait ARQ. And in this one, simplex stop and wait protocol, the signal is transmission which is send the frame for the communication. So it has to wait for the positive acknowledgement time as well as the negative acknowledgement time. If there is no error transmission, there is no error in the transmission, which we calling as a positive acknowledgement received from the receiver to the transmitter, so we don't bother about the information damage. But if we get any kind of negative acknowledgement we received from the source B2, which means receiver to the transmitter, so we again a retransmission from the old packet, which means the retransmission from the previous frame, which we getting the error of negative acknowledgement. So there is a possibility of information of acknowledgement may get lost. And the sender, what we equip with the sender, it has to be recognize the acknowledgement values only, because once the based upon the acknowledgement service values only, because the recognizable acknowledgement, which means a positive value or else which may be a negative value. This value is purely based upon the acknowledgement services. We get the positive acknowledgement, we initiate the next frame transmission. We get the positive acknowledgement, next frame is automatically transmitted. But we get the negative acknowledgement, we are retransmit the entire frame, which is damaged frame. So that is the reason we calling as a stop and wait protocol to get the information from the acknowledgement. So it has to wait that amount of time, that random amount of time. After we get in the acknowledgement, then it has to initiate the next process. That we calling as a stop and wait mechanism. And next one is the noisy channel. First one is stop and wait ARQ. What is stop and wait ARQ? So which we calling as a automatic repeat request mechanism, which is similar to the previous ARQ mechanism, previous stop and wait protocol. But here the very small difference is there. The difference is the sender is send the one packet, it has to wait for acknowledgement. But when the next packet is delayed, next packet is transmitted, so it has to receive the acknowledgement from the previous packet. So here, so this amount of time we have to wait for the value. If any acknowledgement is getting the failed value, if getting any kind of negative acknowledgement, so automatically the packet is retransmitted. We calling as a automatic repeat request mechanism. In previous mechanism, we have to initiate the retransmission process. We have to initiate the repeat request process. But here, automatically the repeat request process should be initiated. So here, the main problem faced in this stop and wait ARQ, once we get the loss of data package or loss of acknowledgement or delay of acknowledgement. So for example, assume that one I am going to transmit the frame 1 from transmitter to receiver, right? So but due to the frame is successfully transmitted, but I have to initiate the process. So I have to take an information from the receiver whether the frame is successfully received or not. So I need to expect a positive acknowledgement value, or else I need to expect the negative acknowledgement from the receiver section. So if this process may be delayed, right, or the loss of data packet from source to destination, so say that some amount of information may damaged, some amount of delay should be happen. So we are not prescribed for that one. We are not rely on this process. That is a major problem we are facing in the stop and wait ARQ mechanism. And when you see this one, so here the few examples are there. One is lost or damaged frame. What is lost or damaged frame? I insert the information. So what I assume that one, the frame 1 is the packet is successfully transmitted, but due to some signal collision or due to some uninterrupted noise, so the packet is not yet transmitted. So what I assumed that one information is transmitted, but information is not received. So between the session, the packet is lost. So I need to wait for random amount of time. I need to wait for this random amount of time. That delay time is very higher while we compare to the, we get the acknowledgement from the receiver section. This delay is very high rate is there. That is a major problem is there. So after some random amount of time, so we assume that one, we are waiting some random delay time. We assume that one, this packet is not successfully transmitted. We again reinitiate the same packet. That we calling as a lost or damaged frame. And similarly, a loss of acknowledgement. The frame 1 is successfully transmitted, but in the receiver section, the acknowledgement may fail or will not receive successfully. That we calling as a lost acknowledgement services. And similarly, we calling as a delay acknowledgement or delay transmission process. Maybe data rate is very low or due to some uninterrupted noises, the delay should be taken. The information transmission from either receiver to source or source to receiver, the delay time should be very higher. That also we are facing one issue that we calling as a delayed acknowledgement. And another important one we calling as a sliding window protocol. So sliding window protocol is reliable and a sequentially deliver of data frame. So previously, so there are no sequential method is followed. The information is continuously transmitted. If any frames are damaged or lost, we initiate the retransmission from respective frame. But here the frames are very reliable and the frames are transmitted in the sequentially manner. The frame 1 after frame 2 after frame 3, this should be followed in the sequential manner. So in this protocol, multiple frames sent by the receiver to the sender at a time before receiving an acknowledgement from the receiver. Because the sliding window protocol, which means the windows are changing by changing while in the receiving section. The window should be shifted from one frame to another frame to another frame. The sliding kind of mechanism should be followed. How in the sense, for example, we are able to transmit the frame 1, frame 2 and frame 3. So entire thing we are calling as one packet. So we are going to transmit these 3 frames, these 3 packets into one time go. So here, so first the frame 1 is successfully transmitted. So here the frame 2 shifting into frame 1 position and frame 3 shifting into frame 2 position. This kind of sliding kind of interruption should be happen. Sliding kind of changes should be happen to the previous positions, that we calling as a sliding window protocol. But here the sequence number of frames, a n bit, and sequence number that can be assigned to the 0 to 2 to the power of n minus 1. So this calling as a 0 frame, this calling as a 1 frame, and this calling as a second frame. But what is the total frame size? We having frame size is 3. But the arrange should be in the form of this 0 to 2 to the power of n minus 1. That we calling as a arrangement manner values only. So the best example when you see this one. So we are going to transmit this frame 1, which is 0, 1, 2, 3. We are going to transmit this window. This we calling a sending window and this we calling as a receiving window. So here the window size should be 4 bits. We have window size should be 4 values are there, and the sequence number that should be changing from 0, 1, 2, 3 and 0, 1, 2, 3 expected. So like this one. So here this window is thus frame is transmitted. After this position received 0, 1, 2, this window should be shifted to the next cell. So the window size should be shifted to the next sliding mechanism, to the next sliding mechanism, to the next sliding mechanism. Still the process is going on like that. That process we calling as a sliding window mechanism. And apart from this one, apart from this protocol, we are going to discussing about another important point which we calling as a piggybacking. So what is meant by this piggybacking? So in the previously we discussing about this a simplex protocol. What is simplex protocol? The information is transmitted towards only one direction. So but while we transmit information, if any information is damaged, that should be major cause for us. But to overcome that kind of issues, so to improve the efficiency of information transmission in the bidirectional protocol, we are going to use this piggybacking mechanism. Because what is meant by this piggybacking? So we are carrying the frame values, how much amount of information we transmitted from source to destination. So what kind of frame we follow that one. So we need to follow the data frame from A to B value, and this carries control information which about how much amount of information is lost, whether go for this 1 frame or whether go for 2 frame. That amount of we are noted in this section values, and that will carry the entire information the end section values, and noted in the frame A values only. So that is a major advantage of this piggybacking mechanism. And another important advantage, the available of channel bandwidth. If any channel bandwidth is free at that time, so we can go for this reuse of that bandwidth, the respective channel. That is a major advantage of this, the piggybacking mechanism. But what is the disadvantage? So the complexity, because while we assign the channel to next allocating channel values, next bandwidth values, there should be simply complex values, and this layer it has to wait long amount of time to signal transmitting to get the acknowledgement. That is a major disadvantage of this piggybacking mechanism. So, and here the another important one is we calling as a sliding window ARQ protocols. So in this sliding window protocol, we have two things are there. One is go back and ARQ as well as selective repeat ARQ. So we'll see this one, go back and ARQ, which means so we having this n number of frames we transmit here from source to destination. For example, we transmit 0, 1, 2, 3, 4 and 5 frames are transmitted. 0, 1 is successfully received, but due to some here the frame 2 is damaged. Due to some is frame 2 is damaged, and sequentially the other one also damaged. So here we go for this, we have discard the frames and again we reinitiate the frame 2, 3 and 4 and 5. So which means we go back and ARQ. When you see this one, frame 0 is successfully received, frame 1 is successfully received, but bit 2 and 3 is damaged. So that should be discard. But after that one, 4 and 5 also transmit successfully, but we discard that one. What are the frames we damage from that frame onwards? Again we go for this reinitiate the process. That we calling as a go back and ARQ. And selective repeat ARQ, in the previous one, what is the issue we caused here? Once these frames are damaged, but these frames successfully received, but we have to initiate the process of all the frames down the line which frames is retransmit, which frames is damaged. But in this selective repeat ARQ, so which frame may damaged? So we initiate that frame only, that we calling as a selective repeat ARQ. So for example, we transmit 5 frames we transmitted. Frame 0 is successfully received, frame 1 is successfully received, frame 2 is damaged, but frame 3, 4 and 5 are successfully transmitted. So in the previous case, all the frames are retransmitted, but in this one, the selective repeat values only, the frame 2 values only retransmitted. That we calling as a selective repeat a frame should be initiated. That we calling a selective repeat automatic repeat request mechanism. So to conclude this session, so in this session we are going discussing about different protocols in data link layer, which is noisy one as well as noiseless one. So in this one discussing about the multiple protocols are there, which is we calling as the simplest protocols as well as stop and wait protocol. Here also this also similar to the protocol values. Here discussing about this automatic repeat request manner values only, that we calling as the noiseless and noisy protocols, which we developed, which we are used in the data link protocol. And another next session we are going discussing about this HDLC. So this is a very important HDLC, so signal transmission. So how we are able to design the HDLC frame, which is also a hyper division of logical link control mechanism. How we develop that kind of link control frames. So these frames are much more different to this data link frame values only. So in the next session we are focusing about those HDLC protocols.